now I'm actually going to be talking about a special operation that we can do on vectors. It's called the dot product. Some people call it the scalar product, because we take two vectors and what we wind up with is a scalar value. So if we have two vectors, we have the black vector and we have the purple vector. What I want to do is I want to say, how similar is this vector in black to this vector in purple? Project this down here, like I'm shining a light up, basically like a negative y direction. How will it project down here? It'll be something like this. It'll be this length. How do we define what that length is going to be? We'll call it projected length. So we know it's going to have, so if we're projecting just this vector, and we give it a magnitude, I'll call this one A, and call this one B again, just the magnitude. We would say the projected length of A on this axis in which B lies is A, which is the maximum it can be, multiplied by some scaling factor. If we call this theta, the angle between the two, it'll be cosine of theta. This is just like the scalars we were applying to vectors a couple minutes ago in the same video. This is just a scalar. This is a vector. Well, sorry, this isn't a vector actually. This came from a vector. And now it's just some scalar quantity. But this is the maximum magnitude that A could have been, and we're just scaling it by a number, which is allowed by our rules of vector arithmetic. So what I'm getting at is the dot product is sort of a projection. Now what the actual dot product means to do is, and it's typically written like this, we have A vector dot B vector. And what that means conceptually is, look at A vector and look at B vector. How similar are these two vectors? If they are extremely similar, which means they're in the same direction, then their maximum magnitude is going to be A times B. If they're not that similar, or if they're slightly not similar, like they are right over here, notice there's an angle between them, so they're not similar. Similar means there wouldn't be an angle between them. Then we have to figure out how much to reduce this value by. And we need to reduce it by cosine, as we said before, of the angle between them. So, when we ask what the dot product is between two vectors, what we're really asking is how similar are they? And we get big numbers when they're similar. Because if we go ahead and just look at the unit circle in terms of like xy values, we know that sine is like this, and cosine is going to be like this, where this value is 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we can see here, if they're similar, this is going to be a 0. When this is a 0, we just have the magnitude of a times b. When they are dissimilar, as the value starts to drop, cosine of 0, which equals 1, and which is why a times b times 1 is the largest value we can have here, begins to drop as the angle starts to increase away from theta equals 0. So small numbers mean they're dissimilar vectors. And just to be extra thorough, when we take the value of two vectors a dot b and we compare how similar they are, this operation gives us a scalar back that lets us know how similar it was or how different it was. As an example, let's go ahead and look at some vector arithmetic, combining some of the ideas we just went over. Say we have some vector A, and we'll have some vector B, and let's say we have some vector C, based on like mentally breaking them up into components. Okay, so this is C. So here we can say that C is equal to A minus B, right? It's pretty similar to the two vectors we just talked about when dealing with subtraction. And if I want to know what C dot C is, I'll plug my C in twice and we'll get A minus B squared, and we know that this comparison is going to turn them into a scalar value. So by the binomial theorem, when we expand this, it's going to become A squared minus 2AB minus b squared. And because we don't exactly know what this angle is going to be every single time, we're going to have to account for it. And the way we account for it, because we don't know how similar these are to one another, they can vary depending on whatever angle we want to make in between them. So we say a squared minus 2ab. You guessed it, cosine of this angle, we'll call it theta, minus b squared. And lo and behold, while you didn't even realize it, you just derived the law of cosines.